Hey people, we're pretty early today, but I was ready and I was like, let's go! So here we are. Of course, then you'll notice I didn't prepare something, or we'll find out later, but then we'll just do it during the show, right? How is everyone doing this evening? And, well, we're doing a non-LED topic again. We're using an LED controller to test it though, but, you know. I am thirsty, so I'm going to go for some zero sugar Fanta and some lemon. Yes. Better brought the nice Danfoss actuators. No, these are actually actuators from Aliexpress. The music's still kicking. There. And some Ultra. No Ultra drink today. No need. The drink is fine as is. Yeah, but I think we're going to take an Queen LED AN Deca Plus, and we're going to reflash it with ESPHome just to have a bit easier control over it. And then we're just going to try it. Does Danfoss have 24 volt thermal actuators? 24 volt Danfoss actuator. Danfoss TH Motor TWAV NC24. It seems like they do. Sanitairwinkel.nl. Whatever. Wow, that picture is bad. Okay. But is it 24 volt AC or DC? For some reason with these things it doesn't seem to matter. They take either AC or DC. Okay, this is a bad shop. Danfoss has their own website. Good. The wax-powered actuators. Yeah. Decline all. Okay. It's a heating element, so it will always work. Yeah, that's the idea. That's why I also think the control needed for it is going to be pretty simple. But we'll see. Oh, Danfoss data sheet. Nice. Oh, I saw clones of these on AliExpress. The minimal dimensions, patent protected protection for leaking valves. Ooh. Okay, they have NC and NO. Yeah, 24 volt, 1 watt. Okay. AC or DC. Well, who knows? I bought a box of AliExpress stuff this time, Maybe in you know, for the actual application, I'll use these. Who knows? I mean, this has to run for like 10 years or so, or at least. So buying a brand wouldn't be bad. Then again, how much better are they? I don't know. Well, currently I'm just testing to see how I can control them. I'm hoping some N-channel MOSFETs will do it. And if that is the case, I'll probably design a board for it so that I can use that board for the underfloor heating distribution panels in the new home. But we'll see. We'll see. A Zigbee water valve for my garden irrigation. Water hammer is legit now. Water hammer? What's a water hammer? When the valve closes instantly, creating a massive pressure spike. Well, that's why we have these thermal regulators. They open and close pretty slow, from what I understand. If I look at the... this is the Danfoss data sheet. They seem to close and open slowly. There's some dead time involved. That's good to know. On page 3 of that PDF... will you use Home Assistant? Yeah, that's the idea. So ever since I built the current home, one of the things I didn't want to bother with because I was too busy doing the lighting and other things was the heating regulation and stuff like that. So I bought this many €1,000 Honeywell system, and I've made videos about it in the past. Well, we're now like 8 or 9 years in the future, and it's still crap. It is the most crap system I have ever worked with. I need to reprogram it at least twice to 3 times a year to switch it from heating to cooling. And it's just an uninsightful, colluded, doesn't do what you tell it to, then suddenly it does. Sometimes rebooting it, fixes it, stupid system. So, never again. And, well, controlling some heating valves, you know, when the room is asking for it all through Home Assistant, that sounds like a good idea. So, you know, this is a part of that. Seeing if we can make these actuators work, what kind of circuit they need. And then maybe I can use one of my existing boards, or I can use, I'll make a new board for it. I don't know. Oh, you have LockZone. Yeah, LockZone's nice, but I've been looking at LockZone. Holy shit, that's expensive. Yeah, if you want like 100 lights, oh. Did you try to fix the Honeywell with a hammer? No, actually the last comment from Honeywell themselves, and I gave up after 2 years of harassing them, and they just left it like that, is like, well, you need to buy everything double. So buy 2 thermostats per room that are like €120 each, and then buy 2 central management units, and then have some convoluted wave hooking that up to the central heating system, which can also do cooling, and then I think we can make it work. That was their official answer. I had to spend another few $1,000s to fix it, while it's just their stupid software that doesn't work. And then I was like, yeah, no, that's not going to happen. Did it myself, save some money. Yeah, okay, that I can imagine. Yeah. That's a great looking datasheet. Yeah, that's a good datasheet. I appreciate a good datasheet. And these don't actually seem to be too expensive. I see them for like $23. Yeah. Let's see for the number. The thermal actuator ABN FBH. Can we buy that? No. Yes. Pro Shop has them. Oh, $40. Yeah. Still, if it's a better quality, you know, that might be worth the investment. But yeah, I think it'll be as simple as just you having an N-channel MOSFET cutting off the ground while keeping positive applied, basically the same as we do with LED strips, and then it'll just work. But that's what we're going to test today. We're going to use an AN Penta Plus that has an N-channel and P-channels in there, so... Yeah, I mean, the Honeywell hardware hasn't failed a beat. It's fine. Their software is just, I don't know, it's just other shit. So yeah. Hey there, Slicer. So let's say hello to everyone. We're still in the pre-stream, but another day in paradise, says Mikea1821. Just in time, says Rod Murray, when he's an hour early. Hi everybody, be a good night tonight. Oh, I hope so, says Nigel Young. And then Greg E., there could be a significant chance of both smoke and flooding here tonight. You mean over where you are or where I am? I'm not sure yet. But the safety glasses provided by Draadstaal are still here. So, and then we got into a Dutch Maker is here and buzzed. Finally can be here live again. Good evening, everybody. Jamie Fairhurst, hello, here for the smoke. And then Rob Gills started talking about Donfos. You know, if they're affordable, that's fine. No Ultra today. Dutch Maker. Rod Murray. You need a slowly closing valve, yeah. Drukgolf. Yeah, the wax ones are slow as a snail. Yeah, exactly. Here is just 12 p.m. Oh, well, here it's 21 p.m. So, 35 in Arizona. Just need smoke. 35 what? 35 degrees Celsius? Holy shit. It's cooled down a little bit over the last few days here in the Netherlands. That's been nice. I also wonder if you can PWM these. Because in theory, for something electrical, PWM, like if you measure it with a multimeter, will just measure, like, you know, average voltage. So, 35C, but only in afternoon. Only noon, what? Controller go bad, motor go vroom. Okay. Oh, you did some sketchy stuff today. 6-story high sculpture that rotates with a big motor, which is controlled by a lighting controller. Okay. Oh, and another, finally, there's bugs here. I bought my first Quinn LED board, an AN Penta Plus, for controlling some Oxmer strips in the living room. Yeah, that'll be awesome. No worries there. So let's wait a few more minutes for people to trickle in, and then we're gonna, I don't know, for fun, we're gonna install ESPHome on this AN Penta Plus, and then we'll see. 3 p.m. in my time zone in Atlanta. Georgia in the US, it's hot here, 34 degrees. Choose. That's warm, Monty. Hope you have air conditioning. Oh, I don't drive there very often, but I have seen it actually. If I come from the freeway to either go to the train station or the movie cinemas in Den Bosch, it's like in a stairway or staircase, I think, in one of the buildings. Yeah. One of you didn't slam the like button. We know who you are. 26 in Anaheim. Oh, okay. Seeds of change. Okay. We're using a prototype board today. Of course, why not? I'm the only one not using production boards. Evening, Quindor. It's been 2.5 months since your last Quinn box. Starting to worry you might have bought everything. It's already been recorded. So, there will be a Quinn box soon. Air conditioning is a requirement here. It's running constantly. Yeah. 35 degrees is just too hot for man. Man's not hot does not apply. Man is hot. Okay, well, I think we can slowly start preparing. What do you think? So I have an LED strip here just to test if the configuration is going to work in a minute. Let's see. Do I have USB-C here? Yes, but I don't need this one. I need this one. Oh. Okay, yeah. Well, let's first make a 45C in Israel. Holy shit. That's gonna... Whoa. I'm glad I'm in the Netherlands. Okay. 36 years. Yeah, on Tuesday. Yeah, I don't know, man. I think we're all going to die, Draadstaal. So, let's see. Where's my Home Assistant? My Home Assistant's over here. Let's open up, let's see, here. Analog, Quinn LED. Oh, wait. I need to share this. Window capture. This one, I think. Why is it over there? And wasn't it transparent? Filters. No, wait. What? Let me find the other one. Is this the transparent one? No. Is this the transparent one? Yes. So I need to copy this one. And remove this one. Yes. Hold on, almost there. There. Okay, now we have the transparent window again thingy, so you can see me. Whoa. And also what I'm doing. So I went to quinnled.info. Let's go to, oh, that's a bit big. Analog LEDs. And then we go to AN Penta Plus, and there's lots of articles here, and the article we need is the ESPHome configuration help, and we're just going to copy this to the clipboard, and then we're going to create a new device. Sure, I want ESPHome web, new device, continue, we're going to call this Actuator Testor. Actuator Testor, yes. Next. So I don't need all this. Okay, whatever. Skip. Okay, and then we're going to edit Actuator Testor. Oh, this doesn't matter. We just paste the example configuration over that. We'll go over it in a minute. We need to go up. So we're going to call this the Actuator Testor. This is all fine. We're going to enable Ethernet. I don't know what address we want to use, so I'm going to uncomment this for now. Wait. There. Hey there, Piotr. Let's see, we've got I2C, we're not going to use that. We've got some API and OTAs. I'm going to set the reboot timeout to 0. 0 is not allowed? Oh, 0 seconds, okay. In theory, that disables the reboot timeout. That's fine, because we're not going to really connect it to Home Assistant. So this is one thing we need: a digital power relay. That's an P-channel MOSFET. So okay, and then we have some LED channels. We're going to leave those at 20 kilohertz and just configure it as default. And it has a default transition length of 1 second, so that means we'll be dimming it up and down. We're just going to try that, see if that's a problem or not. We're just keeping them LED channel, and we have some inputs. Okay, save, install, manual download. So let's compile that real quick. Those errors are because of the Ethernet. I think that's something in the new version, but it does work. And we want the factory format. And then Chrome will say, oh no, what is this? And you say keep. So now let's connect it to USB. Wait, with this one? Yes. So we're going to connect it to USB over here. Where is it? There. We have to enable the USB. Okay. We downloaded it. So then we go to our second tab where we already had this open. We select our COM port. Install. Choose. Actuator testor. Factory install. Okay. And let me open my router software to see what IP it gets. Log file. I was looking at my log file like, what? How can the board be online? But I just plugged in USB-C and that also powers it, so. Oh, I just realized the controller isn't on in the screen. Okay. Anyway, the install is finished. So let's disconnect it. Let's get our Ethernet cable. Okay, and plug that in. There. Let's plug in USB again to see if it comes up on Ethernet. Yes, it does. Good. Let's see which IP it gets. 1010, 120, 130. Okay. Okay, yeah. So I got 1010, 128, 230. That's good. And then let's go back to here. Close. And now we can use the use address. And say it's 130. Save. And if we now do an install through the network. In theory, it'll be able to contact the module and upload. It's currently drawing 0.8 watts. Whoa. Okay, yeah, that worked. Cool. So now we have this guy, and we have 5 outputs and a digital relay output we can use to control the actuators. Good! Well, that was the start. So now let's wire it up. Well, this can stay here. Okay, let's move this. Okay, so we have a box here. Oh. Okay, I keep hitting buttons. And the box, well, it's an Aliexpress box. And it has 5 times NC and 5 times NO. Now, NC stands for normally closed. So without power applied, the thermal actuator is closed. So it doesn't let water through it. And NO stands for normally open. So the thermal actuator is opened. So it does allow power through when no power is applied. But if you then apply power, it closes. So let's get one of each. Let's start with one. I mean, we'll probably end with one. So let's take a look at these. Oh, there's a manual. And a normally closed one. NO and NC valves instead of only actuators. Oh, I don't know about that. I think this guy determines if it's NO or NC, actually. Not sure, though. This one I already unpacked. So they come in a plastic baggie normally. And the way you can tell them apart is this is normally open. And the one with the red on it is normally closed. Wow, they actually have a different manual for it. Let's see here. See, 24 volt normally open. That is without the red thingy. And 24 volt normally closed with the red thingy. With valve status indication. Oh, this also has valve status indication. Where is the valve status indication? Is it just this part that's going to go up or down? I don't know. I mean, I don't know how it's supposed to look. Okay. Well, we'll see. I think the pin is going to come out either on this side or this is going to move. I don't know. We'll see. We're going to be waiting for a while for these. Kind of hoping the valve indicator is a buzzer. What? That'd be annoying. Let's see in the manual here. Voltage 24 volt. Consumption 3 watt. Stroke length 4 millimeter. Okay. Stroke duration 3 to 5 millimeters. Okay. Do not use tools. No. Hand tighten only. As far as the manual goes, that's actually not bad. Yeah? They look very similar to your Tato system, but wired instead of batteries. Yeah, I'm tired of battery sensors, man. I'm going to design the new home without battery-powered sensors, because I am done replacing batteries, like, every few months. Ugh. 3 to 5 minutes sounds accurate for most... Yeah, for most men. Oh, okay. I don't know about that. Okay, let's take our AN Penta Plus. We got a nice baggie. So we need some positive, some negative. We need some positives over here. Well, let's just plug them all in. Me too, no battery. Yeah, it sounds fun, but then it isn't. Okay, that's all the plugs for the AN Penta Plus. Good. So to hook it up, well, let's first hook up power, and we'll do that with the bench power supply, so we can measure the power usage. Oh yeah, I always, yeah. Don't think I can make that work. We don't need a lot of power. Do I have a couple block here? No. Yes. Let's take one of these. And then need some wire. Don't have any wire here. No. Oh, yeah. Don't. No. Okay. That's a bit big wire, isn't it? There. That should work. I think. Let's take some of this wire and make a janky solution. Wired remote. Okay, well there are exceptions. My remote is solar powered and works for like a year without even solar powering it, and then you just have to put it on its face and it'll recharge itself. So that's okay. It's just all these blasted sensors in all the rooms that are all on batteries, and yeah. Did I square these? No. Okay. So let's try and make, no, this is a janky solution here, but it's always a problem jamming this in. Okay, I need to find one that also has some fork styles. Do you have fork styles? No. No. This one does. Oh, it's double fork. Damn it. I don't have any. Okay, I'll make them. Oh, this works. That'll work. We don't need a lot of power, I think. So we're just going to do it like this. So we're going to put it in the fork and then push the fork in. That should make a pretty decent connection. Squish it down. There. All set. Good. So let's do the other side. So put it in the, okay, for some reason this side's harder. Well, of course it's now attached. Okay, put it inside the fork and force it in. There. Don't do this at home. No, only do this on your test bench. Yeah, this is okay. This is okay for testing. Okay, now we have the type of connection we need. I'm not patient today. That's going to be a problem with thermal actuators where you have to be patient to see if anything happens. Oh, we could use the thermal camera to see if anything happens. I don't know how warm they get. Magic smoke chances are increasing. Yes. Okay, let's see here. We have these giant beefy terminals and we put in an 18 gauge. How far down do I have to go? Oh, okay. Of course, I'm doing the wrong thing, screwing them in while they're inserted into the terminal. Shouldn't really do that, but... Later, Jamie. No, this didn't go in, damn it. Wow, how often do I need to turn this? I guess I'm used to using a larger diameter wire in here. Okay, that's secure. Red to red. Red to red. Yes, okay, good. Now, we have these actuators. This is the normally closed one. I guess we'll put that on L1. But now we have to determine what is positive and what is negative. I would say brown is positive and blue is negative. But you never really know with these people. They are nicely... they put a ferrule on here. That's nice. Look at that. That's above and beyond. It's a decent length wire. So I would say this is positive, but what do you guys think? I'm waiting for some replies. Brown is positive. Brown is positive. Same, brown positive. Oh, damn it, these bugs. Well, it's I'm in the garage and it's summer again. Brown positive. Okay. Good. These are all open. Could be just YOLO it. No. So these are going to go here. We're going to try N channel first. Okay. This is the normally closed one. We'll put the normally open one on the other channel. Oh, you had a Meanwhile PSU die on you. Okay. Okay, so now this is secure. Yeah, secure enough. Now we have two thermal actuator valves. And they are connected to L1 and L2. I guess we put on the safety glasses now. I'll take these. Instructions didn't say. Oh, that's a good one, actually. Let's see. Nope. Bad instructions. Is this... yeah. Okay. So we plug in the power supply. Turn this one off. Okay. And I guess we turn this one back on. I'll make it a bit smaller though. Okay, so we give it 24 volt. And let's give it, I don't know, 2 amps. You know. And, okay, let's power the controller. Do we get Ethernet blinky blinky? Yeah, we got Ethernet blinky blinky. That's good. So then we should be able to refresh this. Yes, we can. Okay, so then we need to do a test to see if the configuration is correct. So for now, I'm just going to jam an LED strip in L1. And if the LED strip lights up, L1 is actually what it says it is. It is. Okay, good. Then we know that. And we can remove the LED strip. Do they open fully at 24 volts and maybe only slightly at 12 volts? I don't know. We'll try some PWM later. Currently we're drawing 0.72 watts. Let me enable actuator tester 1, L1. Let's go. Oh, wow. Okay. Wow. What? When I enable it, it hit the output limit. So let's raise the limit to 5 amps. Or maybe something's wrong. Who knows? Can I show you this? I don't have a spare camera right now. Oh wait, I can just put this on the desk. That's why we made it portable-ish. Somewhat portable-ish. There. Okay. So we have the power supply on the desk now. Measure the coil resistance. Oh, maybe later. So we're currently drawing 0.072 watts. So let's enable actuator 1 again, but now we're set to 5 amps. The MOSFETs in here can easily handle 10 amps, so that shouldn't be a problem. So let's enable actuator tester L1 again. And there. Oh, okay. It went up to 2 amps, and now it's ramping down. Okay, slowly ramping down. So I don't know. Oh, I can feel it doing something. Is it moving? Oh, you're not supposed to put it upside down. Let me get the thermal camera, see if we see something on there. Okay, the wattage is slowly going down. I wish I could stream the thermal camera, that's why I bought this model, but their software still isn't working, which sucks. But if we look at it like, let's see, there, oh, this is my hand. Oh, stupid hand, okay. Let's put it like that. The cable is 40 degrees. I don't know why. Probably because I touched it. Or maybe, no. Where the cable is going in, it is 40 degrees. Oh, okay. Down here it's also warm. It is 34, 35. But the cable is actually the warmest. That I don't know if the tab does anything. It's to differentiate between normally open and normally closed. But I don't know how to actually tell when it's done. So we'll switch to the blue. What do you mean switch to the blue? No, it's working. I mean, the top here is slowly warming up, I think. 38. Yeah, it's now 40 degrees. If it's cold and you remove the red ring, it shoots back in. Okay. But it seems the top here is heating up. Oh, it is coming out. I think. If you look at it this way, I think that top came out. Yeah, no, I think this top is coming out. If you look at it close, if you look at this one, you can see it's fully shut, and the other one is moving up. Okay, so let's leave it on the desk like that. Exactly what... No, I think the red part needs to stay on there. It's not in the area where it goes up and down. Right? So it can still go up and down. Trying to see on the bottom, it's 44 degrees now. And over here on the top, it's about 40-ish. And the other one's cold because it's not turned on. Wattage-wise, we've gone down a lot. We're only using about 3 watts, excluding the controller now. Well, it doesn't say in the manual. The manual says nothing. They still have the little red thingy on there. We can try swapping it later, Stefan. Okay, Edward. It says it also on the Ali side. Okay, but then... Okay, it does write NC on here, and this one doesn't have NC. Okay. I'm gonna see what happens if we leave it, and then we'll pull it. Okay. So I think it's settled. It's not moving anymore. So we'll disable the power. Let's turn that off. And in theory now it starts to cool down, so this should go down. So we don't need to see the power anymore. Is the music okay? Not too loud? Hey Philip! We're working with thermal actuators from Aliexpress. Kinda low. Okay, well, in my ear it's a bit loud, so... But I'd rather have it kinda low than too loud, so let me lower it on my side. So we blow up everything. Well, no, nothing yet. The sun is going down, so I'm going to have to adjust my cameras a bit. There. It's basically waiting for paint to dry stream. We're waiting for this to go down. Can we test one at 48 volt? Yeah, sure. We can do that. Okay, Greg. Yeah, I believe it. I believe it. But we're let's leave it for like this then, because I think it might need gravity a little bit. Music is good. Okay, so let me check the thermal camera. Oh, it's still 47 degrees on top. Okay. Works for food anyway. Yeah. There. Oh, now it's 45 degrees. It's strange that the... let me try and show you. The area where the cable is the hottest. But the top is also warm, and that's, I guess, where the wax is. Still, 40 to 50 degrees, nothing to worry about. I think it's going down. Yeah, it's going down. If we look at it, it's now below the ridge, but the red still isn't touching. But we'll see it in a minute. Try the other one, sure. While we wait for this one to go down. I'm trying to think of a way I can show it better. I guess like that. There. And let's try and get the power into the shot. That's oh. That's good enough, I think. Put your fume extractor on it. Yeah, we'll try in a minute. This one is definitely going down. But it still hasn't reached the red ring yet. And I mean, this one isn't lower either. Oh, okay, maybe it has reached the red ring. Okay, let's pull the red ring. There, I pulled it. Is everyone happy now? Oh, okay, now it went down fully. You're right. Okay. I'm just trying to get a good shot. I want to have them leaning here. Something a little bit more. Okay, it is going in further now that the red ring is gone. Yeah, I need to keep them upright and also want to show it in the shot, so that's a bit difficult. Okay, it's almost flush now. Okay, I'll keep them... What did the manual say? The manual said... Nothing. Okay. Hey there, Mech. Yeah, this is an idea I wanted to play with. So, okay, let's try and do it this way. Good enough. Good enough. Let's hit 1 and 2 at the same time. Do you have a set of calipers so you could measure the black cap height? Well, it's about 4 millimeters, so I mean, visually is okay for now, I think. So let's do L1 and L2 at the same time. Boom, boom. Okay, it went up to about, well, slightly below 3 amps, and it quickly veered off again. Okay. I'm trying to see if the second one is working correctly. And we have liftoff. Yeah, oh, that went quickly, yeah. The other one I'm not sure about, though. I also don't see a lot of heat there, so... I'm not 100% sure the second one is working, so I'm going to do a test with the LED strip. Let's put this in negative. And some positive over here. Oh. Yeah, I see light, so that output is on. Yep, okay. I don't see any heat. Let me check again. Oh, okay, now I see some heat and the cable heating up. Yeah, okay. So we see that the cable is heating up and it's slowly heating. So, good. Okay. Yeah, Piotr, I don't like relays for something that's going to switch thousands of times over the years. So I'm trying to see if we can just use N-channel MOSFETs, which will easily last thousands of times switching. Yeah, this is the normally closed one. You can clearly see it raised even on the thermal camera. And this is the normally open one. Seems to be a lot less hot. Oh yeah, this one went down. If you look at it now, it's completely down. Which makes sense. Yeah, so this one comes up when power is applied and goes down when power is removed. And this one goes down when power is applied and goes up again when power is removed. Linear regulate them and use residual heat from the home for heating as well. Nah. I believe it's supposed to move about 4 millimeters. It's actually 3 millimeters. You use PWM to control it, but not sure what frequency. Yeah, that's what I'm wondering about. If you could use PWM, then again, normally in a ground for loop system, you wouldn't really do that, I think. But yeah. Okay. Yeah, that's correct, Willem. So in rest state, when power is applied to both, they both use about 3 to 3.5 watts. That is a lot. But, in the grand scheme of things, I guess you need to figure out if your loops will be mostly open or mostly closed. I don't actually know. That's a good question. I mean, in summer will be mostly cooling, and in winter will be mostly heating. And you want to try and do both with as lowest temperature as possible because of it's a heat pump. So it would mostly be open. What do you guys think? Would it mostly be open or closed? You can confirm PWM works. Well, we can try that. Let's set them both to 50%-ish. Not sure what I use that for, but yes, with a heat pump you can warm or cool your floor. So, it has the same effect. Mostly open. Yeah, I'd say mostly open too. So we set it to 50%-ish, and our power usage also went to 50%-ish. That's good. I was also leaning towards using most of normally open, but I just didn't know actually. You have them open all the time. I only switch H. So let's see if this one will come up and this one will go down. I don't know. Might take a while though. I want to be able to control it per room. So one room might be fine temperature, or it can be warmer or colder than the other rooms, and colder in the winter and warmer in the summer. So I don't need to spend as much energy to either heat or cool it if it's allowed to be a different temperature than the living spaces we're in and stuff like that. So then, does also the temperature now decrease? I guess I need to look at the camera. Hello? No? What? Why? Okay, whatever. There. No, it's still 46-ish degrees. 48. Oh, and this one is now also up to temperature. Okay, 48-ish. Yeah? Okay, well, let's wait. Well, yeah, but I like being able to control it per room, and our current system works with these actuators, so I thought, I guess that's how it works. Use the PWM to reduce power consumption of the actuator. Well, for now it looks like that, but in the end, I would think, it's going to do something. You just did it manually. Yeah, okay, well, I don't mind a few watts of idle usage. I guess that's the way it works. I mean, the ones we have currently probably do the same thing, right? So then again, if you have, let's say, 20 groups, that's a lot. But, that's 20 times 3 watts. That's 60 watts of idle usage. You're struggling with the suspense. Yeah, well, this is going to take a while. I think, with PWM is going to react really slowly. So let's turn them off. Okay, power usage dipped. And let's see if they react a bit quicker. Yeah, new homes, like the ones I have already, heating is not the issue. Cooling is. Interesting. Yeah, Philip, maybe. But this is what is used in the industry. I don't know why. So I'm going to drink a Coke on that. Yeah, but then again, let's say the system fails. It would be better if it's all open than all closed, because if the pump is running and everything would be closed, you normally have a loop that is always going to be open, but still having a larger loop is generally better than a smaller one. Yeah. Cooling is a necessity, absolutely. Let's wait for it to go down. It could take a few minutes. They're not, vertical, so that could be an issue. I don't know, Gvidish. Probably because they don't care about energy usage. Yeah, that's probably... That could be a reason why these are used. Still, I could design a AN Penta Deca actuator, which would have, like, I don't know, 10 outputs, lower power ones, but then have plus and minus terminals next to each other. Because on the let me get an AN-Pentadeca. Because that already has 15 MOSFETs, and N channel seems to work fine. We'll try P channel also, but so while we wait for that to go down, so the AN-Pentadeca, as you can see here, well, it already has 15 channels. That's good. But I wanted to have Ethernet, so it doesn't have that, so that's not good. And, well, we need 15 positive outputs. Now, you could, divide those, but I like having fuses and things like that. Not too much that can go wrong with these things, but still. So who knows? Maybe I'll do a new version that has like 10 outputs and Ethernet. Need to see if I can make that work, but yeah. But why Willem? The few Sonoff TRVs, they're stepper motors, but unfortunately they're battery powered. Don't know. Yeah. Can it be lower voltage than 24 volt? I don't know. Oh, this one's going down. This one has come up. Okay. So yeah, I mean, it could be the same form factor. But you'd likely want like 10 groups or something like that in one spot. And then I can maybe fit enough positive and negative terminals. Let me check how many groups we have now. I don't actually know. Yeah, currently I have 9 groups downstairs, and I believe I have 6 groups upstairs. So, yeah. I don't know, we'll think about that. I just, today is about figuring out how we can control these. Yeah, I have 9 groups downstairs and 6 groups upstairs. Yeah. Okay, well this seems to work perfectly. This one has gone down now, and this one has gone up. Okay, cool. So let's turn off the power. Before we start breaking stuff, let's connect it to a P-channel MOSFET and see if that works. And then after that, we'll do the fun tests. First, we're going to reverse wire one. See what that does. Let's use this one. And then we're going to put 48 volts on it and see what that does. Okay, so these go here. So if you wire an AN-Penta Plus like this, this will have 24 volt with a switch with a P channel or whatever voltage you're putting in. And this will be ground, so that's easy to use. Okay. I'd rather use N channels though if I have the choice. So, okay, we have the power, and let's power it on. Shouldn't do much. Let's refresh this page. Okay, and we have the digital LED power relay here. So let's hit that. Yeah, we see the same kind of usage. It's going down quicker, but I think that is because it's still somewhat warm. So this one should come up. Okay, so if we can use either N channels or P channels, yeah, it's coming up slowly. Using P channels is safer because there's no power applied while it's off. And with an N channel, the positive channel is still live. So, maybe we should use P channels, because then the positive is actually disconnected instead of just the negative or the ground. And if it finds another ground, that could be an issue. Actually, if it found a ground through the manifold, which are often metal, that could actually be a big issue. I think there's just a heating element in it. Yeah. We need to figure out if this is grounded. If it's grounded, we have to use a P channel. Because then positive is cut off, and then if ground is still there, that's fine. But if we only cut off ground, and this is grounded, it'll do nothing. Because it'll just ground through something else. Okay. Well, that worked fine. P channel works. Let's turn it off. Time to get the Dremel out. No, we can just use the multimeter. Jesus. Isn't the double square pictogram related to ground? This one? I have no idea. Not grounded. That would be a huge design failure. I don't know. Okay. Well, maybe we should design against design failures and use a P channel anyway. Right? Does it have a CE mark? Yes. I don't know if it's an official one, though. No magic smoke yet, but maybe later when we put double the voltage on it. Okay, let's go to continuity mode. Let's just turn off power there. I don't have the overlay active, but I'm not gonna for this small amount of time. Let's see if positive and negative are connected. They are. What? Why are they? Oh, 16 ohms. Okay, well that might be something else. It doesn't seem to... This is all plastic inside of here. This is not connected. Trying to really stab it, but no. Is it connected to positive? No. Poor multimeter probe. Okay. No, this is metal. Hear that ringing? That's metal. And this is nylon. So, to stand the heat, I guess. Okay. Well, that works. Okay, good. So, we can use an N channel or a P channel. But what should we use? Maybe we should use P channels so that once you cut off the valve, the positive voltage is actually gone, so that if it finds ground some other way, maybe internally, it doesn't actually get power or make power. From a safety perspective, I think that's better. And we only need P channels that can handle 24 volt up to say 2 to 3 amps. So we don't need a lot. Yeah. Yeah, I'm leaning towards making it P-channel anyway, just for the safety of it. And we can also put fuses on there. We can just put some 2 amp PTC fuses per output, per positive output. Yeah. Use an isolated power supply for safety. Maybe. I'm just thinking about how to wire it up. Since these are relatively thin wires, let's try and see if we can get the wires into these green terminals. I think so. Because they only carry a max of 2 amps for a few seconds and then, it dies down. Is this one opened? I think so. Let's remove the Ethernet real quick. How well do they go into this type of terminal? Easy. Okay, yeah. Yeah, I like the safety aspect of P-channels as well. I really like having stuff disconnected when it's off. And with an N channel, that's not really the case. So, yeah, okay. So these 3.81 millimeter terminals, they take these wires just fine, no problem at all. And I can't imagine the wires from a different brand being very, very different. These are come already pre-crimped with a wire ferrule. That's very nice. Okay, so P channels with 3.81 millimeters. And I think I'd want most of them to be in this single the single terminal arrangement. So kind of like I did it on a Dig Octa Power 5, where you have ground and positive on the same plug, because, well, we're not sharing a plug with multiple things here. So you get a lot of these, but then in 3.81 millimeter, and probably in orange, although that's an extra cost, but I have to see about that. Because it's positive and negative combined, right? Maybe I should stick with green, because I don't think I'll make thousands of these. So then a custom color like we have over here might be too expensive. Although I could do two channels each time, and then still have red plugs. But then I have to make red and black plugs again. And we can only order them like in 5 or 10,000 quantity. So that's going to be a problem. But I really like having red and black on there. And I don't mind the arrangement that this has. So, for instance, you have it like that. And then you have the second channel like that, for instance. Or maybe you do it like this. You know, you have a common ground, because ground is now not switched. And then you wire it up like that. Would that be okay? Because then I can use red and black plugs. Or would you want a single plug per actuator? Yeah, single plug per actuator just makes a lot more sense, right? We can't do colored screw terminals then. But I don't think that's too much of a problem. You'll probably sell 10K or 100K knowing your sales figures. I don't think so, Philip. I wish I sold those amounts of anything. No, I don't think so. But, you know, if I need it, often other people want or need it too. And I think having an ESPHome based board with P channels and some fuses in there, there'll probably be auto reset fuses, because we kind of know the current, right? If we can put a 1 amp auto reset fuse in there, since it's generally going to be at a few watts anyway, you know, we can use an auto reset fuse. We don't have to use replaceable fuses because we know the load. So yeah, and on LED controllers, I don't know what kind of load you're going to put on it, so it has to be a replaceable fuse. Maybe design a terminal block to go from combined to separate connectors. What? What do you mean? You'd be happy either way. Yeah. Yeah, I'm leaning towards having a single plug per actuator. And then you just know left is positive, right is negative. Done. Okay, so now we're going to do the fun tests while I'm still wearing the glasses. How about we put 48 volts on one? Let's take the normally closed one. This wax is going to be 1,000 degrees. I guess just the wax is going to be hotter, huh? So maybe we start with 36 volts. No, okay, we'll start with 48 volts. We'll start with 48 volts. No, wait, no, we have plenty. I have 5 of each. So we'll try 48 volt first, and then we'll wire it in reverse. See, these are good tests. I mean, I need to know how it responds, right? We're going to use the N channel for this. Because I have many N channels in here and only one P-channel. But the results should, in the end, should be the same. I wired it in correctly. Damn it. On your controller, you could have a combined connector for the actuators, and in a terminal block split the outputs in separate connectors. I still don't know what you mean. If you need something external, I don't like it. That's why I designed a controller, to have it integrated. I don't like then you having to use an external splitter. Okay, now we actually have it reversed. But there are reverse polarity diodes on the outputs. So I have no idea what's going to happen. We're limited to 5 amps. I don't know, but I mean, as I said, we have a reverse polarity output diode. That's going to be interesting. The fuse can't blow because it's a higher amp fuse. Maybe the MOSFET will die. Something might die. Okay, let's power this on. Okay, boot it. Yeah. The valve will work as intended. No, I don't think so. I don't know. Go. That's about the same as it was before. Okay, Drahtsal might be right. The valve might just work as intended. Because it's resistive, so positive and negative in DC, yeah, it doesn't really matter. Yeah, true. That's still 24 volt. Yeah. We're doing 48 volt later. Let's see if it works in reverse. I don't think so. Because it's just melting some wax, right? Oh, man. Okay. Yeah, I need to see how many groups I can create while keeping Ethernet. I hope I can reach 10, but I'm not sure. I'll have to take everything off. So no I2C, no extra outputs, no relays, no digital stuff, no nothing of that. Yeah. 400 volt AC. What? Okay, well, it still works normally. So reversing the output wires doesn't matter. I could do that, but that introduces extra cost also. And normally that would be an issue PWM wise. But then again, PWM doesn't matter for this, so I could evaluate it. Yeah, well, I think we've seen enough. Let's turn this off. Turn this off. Wire it in correctly again. No, I want to see if reverse polarity on the P channel makes a difference. So we're going to do it wrong over here too. No, there are chips that do that, of course, but that has all kinds of downsides. That's why my current LED dimmers don't use that. Now, for this, those downsides might not be as important, but if it's avoidable, I'd rather not. But then again, I could base it on an ESP32P4, but that also doesn't make sense. So, Timothy, that's been somewhat delayed. Because of some things I found out after all the latest testing. So I'm waiting for some new chips to see if that solves that issue. And then I hope to continue that. But yeah, it's still in development. No, I don't think so either, but it's good to test it. So let's power it on. Now it's probably not going to draw a lot of power because it's already somewhat extended. So go. Yeah, it went to 2 amps real quick and then went down again. Sure. I need to boot my my thermal camera. Okay. Let's see here. Let's focus. It's about 52 degrees. That's in line with what we saw before. Yep, okay. Let's turn that off. Okay, now let's wire it correctly again. Hey, Alexander, you went to Amsterdam today. Cool. Okay. Do we want to immediately go to 48 volts or do we want to try 36 volts in between? That would actually influence the design if you want to overclock your valve. You know, I need to use higher voltage components. Okay, we have step it up. Okay, 36 volts. There. Okay, we need to cool it off first. Sure. We'll let it cool down a bit. Yeah, this is actually also rated for AC, I believe. There, I blew on it. Let's wait for it to go down. ASMR stream. Oh. Yeah, so this would actually become a very different board, huh? With like 10 or 12 P channels, however many I can squeeze on there, instead of N channels, and then having a PTC fuse per output. Yeah. Sorry, I'm thinking technical things like, do I want to put the PTC fuse before or after the MOSFET? Problem is, no, I think I can still put it before it. The problem is the current spike, and the PTC could limit that, but that's not a problem, because it'll just spike less, as long as the PTC doesn't close. Yeah, probably. I could do that, Medvet, but it's okay. It takes a little bit. So we've hooked it up correctly, and we're going to try 36 volts. I wonder if the amperage will shoot up higher. It probably will, actually, because it's resistive. But I can design it for 60 volts, that's not a problem. Because the continuous load's going to be low, so the extra resistance of a P channel isn't much of a problem either. It will be less, but it will go wrong. I don't know if it'll be less. Since it's resistive and it's getting a higher voltage, it might also draw a higher amperage. For sure, more amps. Ohm's law. Yeah, exactly, yeah. Okay, let's see what temperature it is right now. 36, 46, yeah. That takes a bit to cool off. So let's set ice set to 10 amps. Let's send it. There, you can draw 10 amps if you want. Okay, well it's retracted almost inside now. That's fine. I really wish I could stream the thermal camera, but I can't. So let's go for it. I'll lean back a little bit. So oh wait, I can just turn it on. That's fine. Let's refresh this. Okay. And go. It's about the same. It peaked at 1.8, 1.9. It doesn't seem to be drawing significantly more watts, though. Come on, camera. There. I don't see that big of a difference. Okay, well, it didn't break yet, so let's turn it off again. Should we really cool it down and then go 48? Hold on. I guess we can go up to 60 volts, but I mean, there. This is my solar fume sucker. It produces a good amount of air. Yeah. Solder, not solar. Fan and damp cloth. No, no, no. It's a blower. Well, okay, it's a sucker too, but... I'm not sure it's helping. Yeah. Maybe. You gotta see something new every day, Xmivo. Power is off, yeah, the whole power supply is off. But it's going down, slowly. Let me up the ISO more. There. I guess you can see it a little bit better now. We're at ISO 10,000. Can we zoom in more? Oh, we can actually zoom in more, but then we don't have the power supply in the shot. Let me see if I can get it. There. That's good. Now I need to focus on over here. Yes, all set for the 48 volt test. Okay, that's... Uh-oh, okay. Power up the board. Oh, wait. Okay, let's go to 48 volts. Okay. Okay, the board is online. We can read the power here. We have this guy. Let me turn on my thermal camera. Monty, maybe. I haven't looked into that yet. I've looked at getting one, maybe, but yeah. And the plug would be over here, which would be annoying. Anyway, right. Let's see here. It's currently... Oh, it's still 46 degrees. Jesus. Okay, 48 volt. Let's turn on the power. Let's see what it draws instantly. Still about the same. Yep. I'd say it's melting quicker, but I'm not 100% sure about that. Let's see how warm it gets. I mean, it has to drop down to about 3-ish watts or something. Oh, this is a Lumix S5. And that one over there is a Lumix S5 II. And they're all piped in with HDMI, either copper or fiber optic HDMI to a Blackmagic quad HDMI recorder. So they're all doing 4K 60. And I have some pretty good lenses on there. That's a prime lens. And this is a 24-105 with fixed f4 aperture. Yeah, it's a bit of expensive equipment, but I like the image quality, so I can't stand to look at stupid bad image quality. Let's see what the wattage goes down to, and then measure the temperature. Thanks, Uma Kavula. Yeah, and the stupid thing is, I do everything in 4K, and my videos are all 4K 60, but I can't stream 4K 60 to YouTube, so I actually have to downsample it to 1440p 60. Yeah, then, but why then don't they rate these for like 12 to 48 volts? Oh, you could try 12 in a minute. It's still about 50 degrees. I don't know what they used. It seems to work fine at 48 volts though. 48, 24 is safety standard. Yeah, okay. Yeah, but then when designing the board, I guess I should make it 55 volt compatible. I mean, we can go to 55 volt now. There. That's the nice thing about the A and Penta lineup. They can do very high voltages. You use 24 volt AC HVAC. Yeah, I don't get the 24 volt AC part. Yeah, I guess when I design a controller for that, I need to make it 55 volt compatible, just like this one. I can reuse most of the circuits. Oh, that does give me other issues though with the MOSFETs. I need to look into that. We'll see. We're not going to really do PWM, and if we're going to, we're not going to do it at high frequencies. So. Yeah, I noticed the doorbell also uses that. But that actually has a mechanical reason, I think. Yeah. Okay, we're down to about 3 watts now. 52, yeah. 52.9, 52.6. $55.6. I don't see any difference no matter the voltage we use. Okay, let's turn it off. What is the black thing you're measuring? You mean this thing? This is the cap on top there. No. The AN Penta lineup maxes out at 55 volt. Please do not exceed 55 volt. The indicator? What do you mean? You mean this guy? This is the wax valve, I guess. Right, yeah, so no reason to stick to 24 volt in that sense. Okay, well, I'll design the board to be 55 volt compatible, up from 12 to 55. I need to figure out how to do that with the MOSFETs, but I think I can do that. It'll be a bit more expensive circuit, but... Okay, let's wait for it to cool down. I'll use the manual cooling down method. Because I want to try it at 12 volts. See if it draws more power. Because if it peaks at 2 amps, and we're going to have 10 of these, let's say, that's still a 20 amp peak. So you'd need a 20 amp power supply at 12 volts, or 24 volts. So that's a 500 watt power supply. Wow, okay, I didn't think about that. Yeah, so either you need to build in something software-wise that they don't turn on all at the same time. But normally... Yeah, more amps, I want to see the amps. But normally, they could turn all on at the same time, right? So that could draw 20 amps. Instantly. Okay. How about 6 volts? No, again, the AN Penta lineup is 12 to 48 volts. So, well, 55 secretly, but we don't talk about that. So, yeah, if you have a power supply with OCP, and let's say you put a 250 watt power supply on there, that could actually trip its OCP if you actuated 10 or 12 at the same time. Ew. Interesting. Has it gone down yet? No, it hasn't. A little bit. No, it'll go down, it'll go down. It takes a bit. I need to think about that, because I basically have to design an AN Penta circuit for it with all the power delivery and everything. Maybe avoid tripping it with PWM. Yeah, but then it's going to be a software feature and not a hardware feature, right? Still, we could put in the code that it has to PWM dim for like 10 seconds. Ah. Yeah, we could put in a code that it PWM dims for 10 seconds, and then it's maybe not a problem. Because, I mean, I see these boards running ESPHome, and there you can just set a default transition length to whatever. So let's say 10 seconds. And then it won't draw that much power. It's actually currently set to 1 second. Okay, well, we have to wait a bit. So let's try that. Let's try 12 volts first. I have to still wait. And after that, we'll set the PWM value to 30 seconds. I don't know. And then see if that makes a difference. Yeah, ESPHome's great. Yeah. Then again, that might heat up the MOSFET though. So it might need a beefier setup. Well, it would be on. It would just be PWMing. That's okay. Yeah, okay, that's okay. Yeah, no, okay. Okay, I think it's down enough, right? We set it to 12 volt. Let's boot the controller. Okay, well, let's see what it does. 12 volt power test, go. Well, it depends how big a P-channel I use, but the bigger, the more expensive. The more volts, the more expensive, etc. That didn't use a lot of power at all. Is it because of the lower voltage? Let's see, 24 volts. Power it on. Yeah, that peaked higher. No, I think it actually did less amps. So let's try that again. It seems to be lower at 12 volt than 24 volt. Yeah? Yeah, it's lower. No, not more amps, lower amps. So so it's off again. Let's go to 12 volts. And it won't exceed 1 amp. So give it a second. Hold on. Okay, go. You see it slowly ramping up and going down again, but it didn't exceed 0.6, 0.7. So let's turn it off again. Let's go to 24 volt. Give it a second, have to wait. Okay, let's try it again. Yeah, there, it easily peaked above 1 amp. So I don't think it's drawing full power at 12 volts. So let's go to 55 volt. No, I don't want the peak power, but I just want to test. So let's go. Okay, it hit about 1 amp. All right. So at 12 volt, it doesn't seem to be able to draw the full amperage. Let's give it a second. Okay, go. Yeah, it didn't go above 0.6. Okay, good to know. So it needs more than 12 volt, but it can do 55. Okay, let's go to our ESPHome sketch here. And let's change the default transition length from 1 second to 30 seconds. And just to be sure, we'll do that on all the channels. Okay, save, install. It should just do that through the network. I love how stable the AN Penta circuit is now. I just switched from 12 to 24 to 55, back to 12, whatever, and the controller just stayed online. What was that about not able to connect? Oh, it took a little second. Okay. Born designer must be pretty smart. Yeah. So now it should say, yeah, transition length is 30 seconds. Okay, let's go here. Let's go to 24 volts. And it's had a bit of time to cool off now, so it's likely going to draw a bit more. But now it's slowly going to ramp up in 30 seconds time. So we're at 1270. Oh, you can't see that. Okay, never mind. 15, go. Okay, the power draw is a lot less now, because it's slowly ramping up the MOSFET. There is a gamma curve, though. Yeah, power draw is growing because of, you know, the MOSFETs opening more and more. And now it's lowering again because it's at 100%, but this is thermally saturated, so it's going to go down again. Okay, that is actually a good solution. And since these things are dead slow anyway, adding 30 seconds, you know, which will slow it down maybe 15 seconds, which takes a few minutes anyway, I don't see that as a problem. Although we have to see, edit. Yeah, we need to, I think we can change the default transition length from 30 seconds. I think that you can change it for only when it turns on and not when it turns off. Let's see. Well, I'd have to figure that out. Should be possible, I think. So for wiring's sake, then, what is your length on the runs? Didn't we all want 20? Which runs are we talking about, John FSD? Yeah? We've reached 3 watts, so that's fine too. Okay, let's turn it off. That's going to take another 30 seconds. I'm going to wait for my little timer here. I don't think you can see it. No. Well, I'd mount the controller right next to it. Okay, I turned it off, so it should now slowly start dropping the wattage. Because it also takes 30 seconds to turn off. We're at 1/3. Okay, 2/3. Okay, and it should be off. Yeah, okay, yeah, that's perfect. Interesting. Okay, let's wait for it to cool off and do one more test. But PWMing for 30 seconds seems to be a good idea. Nice. I'm trying to think if that's gonna generate extra heat. No, it shouldn't. No, that should be fine. Huh. Yeah, so this controller would be near the valves, as I imagine it, And I just run Ethernet to it for my home automation, right? So I wouldn't want it Ethernet connected. Yeah. Yeah. Well, this could work. I get that, Mikaela. Have a good night. Later. Thanks for being here. Set the PWM value to 50% to save power. Yeah, I don't know if that's gonna do anything. I mean, in the long term, I'd say it also would then close 50%. Maybe not immediately, but long term, yeah. I'll leave the test running and test that. Oh, sorry. Yes, Dutch Taurus. Yeah, they would be on a distribution manifold. Underfloor heating distribution manifold. Hold on. So something like this, right? So where you have all the groups and oh, what? Okay. Yeah, so this would all be in a central location where you'd have these valves on there. Can I get some images, please? There. What's a good example? Open image in new tab. There. So here you can see the hot line and at the top. That goes to all your lines in the floor. And then on the return, on the cold line, this is from Danfoss, they have these actuators that can either open or close to control that loop.
All right. I'll tell you the truth.
Yeah, John FSD, I mean, PWMing to 50% would be almost equivalent to lowering the average voltage. So it's either going to draw more or it's, going to be at 50% open. So I'll test that. Floor heating, someone is spoiled. Well, it's actually for floor heating and cooling, but yeah.
Remember all the happy times we had?
So we're still waiting for this thing to close fully, and then we'll turn it on again with the 30-second mark. See what it does.
They're very much alike. Remember all the happy times we had?
Yeah, floor heating, and I mean, the way to heat it or to use it for heating is very nice. So, and I don't think it's that much more expensive nowadays, like Philip said.
All right. I'll tell you the truth.
Yeah, same deal. Funnily enough, I think on my install they're actually on the hot side, but yeah. Yes, I agree, Wim. And if you then have stupid Honeywell software, it's stupid. It probably works fine for heating, but if you also want cooling, it's hell. No, no, cooling is actually more important than heating, so yeah. Okay, I think it's fully down. So let's give it the 30-second 24 volt test. Right? Oh, maybe. What okay, so this is the last test. Name the voltage in the chat you'd like me to use. Up to 55 volt. We're not going to go above 55 volt. Oh, wow. Interesting, Philip. True, true. I like the spread out heating much better too. 36, okay. 55. You're all like, overclock this valve to more than double its value. It's rated voltage. 1 millivolt. No, the controller won't work at that. 0.1 volt. Mains. No. No, 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 no. $70 volts straight out of the PSU. No, 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 no. 42.75. That's a bit oddly specific. 12. Well, 55 is winning. Gigawatts. Nope, nope, no gigawatts. $24.22. What? No, I think 55 is interesting to check out. Although we'll see less amps. No, okay. We'll see less amps. But I want to see a lot of amps. Because I want to see the power draw with the PWM. Mm-hmm. I think we're going to stay at 24. Because we're trying to see if we're going to get less of a power spike now that we're PWMing for 30 seconds, right? Okay, I think we've waited long enough. That's the plan. 24 volts, 30-second turn on and off time. Go. Well, it starts out really slow. Oh, it's climbing, it's climbing. Well, 0.5 amps is very manageable. Okay, yeah, interesting. So it didn't exceed 0.5 amps, which is good. Yeah, and it's slowly going down. That should be possible in ESPHome, Josh. But I'd have to look up the code. But in the end, it doesn't really matter too much. Because if I now turn it off, it'll just slowly ramp down, and that's fine. See, it's slowly ramping down. Especially if you have like 10 of these valves doing all kinds of stuff, it might be easier for the power supply. Do you think you can make it smoke? That I don't know. Exactly, yeah. Less jolts is always better for the power supply. What message? Did I miss a message, Philip? Cool. Well, I think that is a great live stream. And also a pretty good conclusion there that... Oh, hold on. Oh, no. That is the wrong button. That we can certainly use these. And you can control them with N channels, with P channels. That's all fine. It runs fine off of 24, 36, 48, or 55 volt. Well, no secret time. The secret is that I'll probably be developing a board for this. Because I need it myself, but then I'll make a few hundred so others can buy it too if they need it. I guess that's going to be one of the first non-Quinn LED products. Huh. How's that? Do we all like the AN Penta form factor? So should I use the same housing? It's nice and industrial. You can mount it to the wall. It's metal. This is a prototype silver version. I didn't like that for the analog dimmers. I might actually use it for the for other stuff then. I will have to rejigger this because, yeah, I need a lot more channels. So I need to see if I'll do that with an external chip or not. Quinn Cool and Heating BV. Yeah, maybe. Yeah, this form factor is pretty good, right? It's not too big. It's not small. That's why we have the AN Penta Mini. But it's not too big either. And I guess right now you could say that all AN Penta Mini or all AN Pentas can be used with heating valves. I'd just like to do it slightly different. But yeah. Cool. Okay, yeah, I'll think about that. But it's not going to be anytime soon, I think. You know, these things take time, especially if I also want to get it certified and yada yada. But, yeah. Alright, I was going to do a 50% PWM test. Okay, let's turn this back on. Low voltage outdoor lighting. Yeah, but then just use an AN Penta, because then you need to control the negative side generally. So, yeah. Let's turn it on again. Because I want to leave it running at like, let's say 40%-ish. See what happens. A fan controller to go with it, yes. And I guess we do also need some kind of relay output so that you can use relays to easily turn on and off a pump or something like that. Maybe some other stuff. So maybe I need the pins. I don't know. Yeah, I don't know what will happen with 50% PWM, but I'll just leave it running and see what it does. I mean, yeah. It's currently drawing 4 watts, so it'll probably go down below 3. And you'd think then that it would also lower, but, you know, I don't know. You're stuck in this chair. Yeah, well, it's nice with a little furry purring fellow there, so... It might smoke at 50% PWM. Well, it's not smoking right now. We can take one last temperature reading, and then I'm going to call it for today. It's rising. So let's see, where are we there? It's still at 50C. Sorry. Doesn't seem like anything changed. And we're drawing 3.6 watts, so that also didn't change. I don't know. I'll test with it. I don't know what the conclusion will be there. But yeah, that was fun. Now I know much better what to do. And it's going to be fairly easy to design because I can adapt some existing designs, except maybe for P-channels. But I'll need to figure that out. But I'll do that. Finally took the glasses off. Cool. Well, I thank you all for watching. I'm going to call it. And I found that very interesting. And I hope to see you all back for a next live stream. Thank you for being here. Or maybe during a video in the comments or on the Discord server. Have a good night, guys. Bye-bye.